Okay, here's the long-awaited Lesson 77 lesson video. It's called Advanced. Everything we do anymore is called Advanced. This is called Advanced Radical Equations and Multiple Radicals. So remember the days when you just had this little radical problem, square root of x minus 1 equals 4. And the way that we solved it was we squared both sides. And that freed what's under the radical, so we got x minus 1 equals 16, and then we just added 1 to both sides, and we got x equals 17. Remember those days of easy, I guess we'd call those simple radical equations. Well, we're moving on to more complex ones, and I actually put example 1 on the other side of my page, so here we go. You'll notice this is a little bit more complex than that previous problem that we did. First thing you have to do is isolate your radical. I feel like we've done these where you have to isolate your radical, but that's the first step. You want to get the radical all by itself. So here we go. We're going to get the cube root of x cubed plus 6x squared minus 4. And to isolate it means that we're going to take everything that's with it to the other side by adding them to the other side. So we're going to add x to both sides, and we get x over here. Add 2 to both sides, we get plus 2. And now you need to free what's under the radical. It's a cubic radical, so we're going to cube both sides. The cube root. So we're going to cube both sides of our equation. And you can see how complicated this is getting already. So we're going to, when we cube a cube root, we get what's underneath the radical, x cubed plus 6x squared minus 4. The complicated part over here is we have x plus 2 cubed, and that's the same thing as x plus 2 times x plus 2 times x plus 2. And you would multiply all of that out. And I don't think I've ever taught you the formula for doing this, so I want to do that. I'm going to try to do that in class this week. There is a formula so that you don't have to multiply this all out a long way. But if you multiplied this all out, you would get x squared plus 4x plus 4. I just did FOIL on these first two, and then I took that one times x plus 2. Remember this? And we would get 8. This would be 8x and 2x squared. And then we take x times both of these, 4x squared, x cubed. Put our pluses in there. And we would get this big, long, ugly mess. 6x squared plus 12x plus 8. And that's what we get when we cube this. So you can see why they're definitely more advanced. So we get x cubed plus 6x squared plus 12x. I didn't leave enough room in any of these videos, in this video for any of our problems. And then the x cubes, fortunately, cross out, and the x squared even cross out. Makes this very easy. And so I'm going to subtract 8 from both sides, so we get negative 12 equals 12x. Then we get x equals negative 1. Now anytime you're freeing things under radicals, it can change the answers. So you need to check and make sure that this works. You have to put the negative 1 back in the original problem just to make sure that you don't get too many solutions. When we put negative 1 back in, we're going to get 1 plus 1 minus 2, and that does equal 0. So this one's checked. Okay, that's the first type of more complicated problems. Let's try one where there's 2 radicals. These are advanced radicals, and then we're going to do the kind that are called multiple radicals. So I'm going to move my screen over here. Okay, multiple radicals. So now we have 2 radicals. We can't just isolate a radical, because when we isolate it, we have 2 of them to isolate. We can't do that. So what we need to do is isolate the bigger radical first. This is a 2-step process. So we're going to isolate this one, which means we're going to get this one by itself, which means we have to add the square root of k to both sides, and we have to subtract 1 from both sides. So that's our first step. So we get k minus 5 equals the square root of k minus 1. So I just took that over there, I took the 1 over there, and now we isolated the bigger of the two radicals. And then we're going to free what's underneath this radical first by squaring both sides. Now, this gets complicated too. So when we square a square root, we get what's underneath it. But over here, we can't just say k minus plus 1. We can't just square these individually. This is a binomial, and the binomial needs to be taken times itself. So it's really square root of k minus 1 times the square root of k minus 1. Now hopefully you remember the rule that I taught you so that you don't have to rewrite this. You square the first one, and we would get k. We multiply these two together times 2, so it's minus 2 square root of k, and we square the second one. And if you did this by FOIL, you should get exactly what I got. Your outer would be negative k, square root of k. Your inner is negative square root of k, and that's negative 2 square root of k. The k's cross out. And now we're going to isolate this radical. So we're going to get 2 square root of k equals 6. So I just made them positive. So I added 2 square root of k to both sides, and I added 5 to both sides. And now I'm going to divide by 2. And I get the square root of k equals 3. Then the final step is we have to square both sides to get the k by itself. So we're going to square both sides, and we get k equals 9. And like I said, you have to check these kind of problems because they can give you some false answers. So if we put the 9 back in, we would get 9 minus 5 is 4. Square root of 4 is 2. Minus the square root of 9 would be 3. So 4 minus 3 plus 1. Or this is 3. No, it's not concentrating here. 2 minus 3 would be negative 1 plus 1 equals 0. So that does check, so this is the correct answer. Let's do one more of these with the double radicals. First thing, isolate the radical that's the bigger one. So we're going to get square root of x minus 8 equals 2 minus the square root of x. Then we square both sides to get rid of the first radical. And so we get x minus 8 equals, you FOIL this, you don't square the 2 plus the square root of this, you don't do that, we FOIL it. So we can FOIL using the little formula. You square the first one, you multiply these two together, so that would be negative 2 square root of x, and we take it times 2, so it's negative 4 square root of x. You square the last one, so it's always going to be positive, and that's going to be x. So hopefully you get that. You don't say 4 plus x. You can't square each term individually. You have to take the binomial times the binomial. So the x's crossed out. It seems to work out every time. Subtract 4 from both sides, so we get negative 12 equals negative 4 square root of x. Divide both sides by negative 4. And we get the square root of x equals 3. And then we're going to square both sides again because now we have our simple radical equation. We're going to square it to get rid of the radical. And we get x equals 9. Again, you need to check these because you can get false solutions. So here we get 9 minus 8 gives you 1. I'll write it up here this time. Plus the square root of 9 is 3. 1 plus 3 does not equal 2. So this does not work, so there's no solutions. Alright, I'm going to give you one to try, and then we'll be done. You ready? Give this one a try. This is actually practice problem B in your book. So right there, stop the video, it's down here, square root of x minus 16 plus the square root of x equals 4. Stop the video, try it, and then check back in a sec. Okay, hopefully you tried it, you didn't just wait for me to do the problem. So, first thing you want to do is isolate x, this radical, the bigger radical. So we're going to get it by itself by subtracting the other things away from it. And I did that already. I subtracted the square root of x. Then we're going to square both sides to free what's under the radical. And over on this side we have a binomial that we need to square. Square that, we get x minus 16 equals 16 minus 8 square root of x plus x. The x's will cross out. Subtract 16 from both sides, we get negative 32 equals negative 8 square root of x. Divide both sides by negative 8, and we get 4 equals the square root of x. Square both sides once again to get the x by itself, and we get x equals 16. And if we check it, we would get 16 minus 16 is 0, plus square root of 16 is 4, and 4 does equal 4, so let's check. So this video is a little distracted. I did it with everyone running around in my house. So you probably got to hear all kinds of interesting noises. Okay, that's it for lesson 77, and I will send you lesson 78 shortly.